Hi, I'm Stephen Buscher, and I'm part of the team behind the AVL Simulation Suite. It's my pleasure today to introduce you to our latest release, 2026 R1. Let's take a look together at some of the highlights and new features in this release.
This release makes it possible to load CAD data in EXCITE M. All typical CAD formats are supported. A new CAD tab in the main menu shows in the CAD model tree and below the EXCITE M model tree. In this example, we load the CAD data of a full eDrive on a testbed configuration. Then, we use the CAD data of the input and intermediate shaft to create appropriate EXCITE M bodies. When selecting a CAD body, the user defines the type of the body and its name in the EXCITE M model. The body appears in the model tree and information, like position and dimension, are retrieved from CAD data. The detailed body subcomponent geometry information can be taken over from the CAD geometry with just a few clicks. This is especially useful, for example, for the gear subcomponent. The user selects the front and rear plane of the gear geometry and two neighboring tooth tip planes, and all the rest of the gear geometry is extracted from the CAD. For the roller bearing seat position on the shaft, the user just selects the appropriate shaft surface, and the model automatically gets the correct subcomponent. EXCITE M components are presented in the same 3D window as the CAD geometry, which allows the user to visually confirm that the body position, orientation, and overall geometry fit perfectly. This way, the potential for user input error is minimized. The bearing seat in the housing is also selected by simply clicking on the appropriate surface and labeling it as bearing seat. In the final step, when all necessary geometry is defined, we switch to the Home tab of EXCITE M and define the joint connection for the gears and bearings. The roller bearing geometry, in this case for the angular contact ball bearings, is refined with some bearing geometry information from the CAD. The setup of the two shafts and housing as a submodel of a complete eDrive that is shown in this example requires only a few minutes. We did not measure or write down any dimensions of the CAD data. No additional CAD tool is required to complete the model. The submodel of the input and intermediate shaft and the housing is ready to run. The first check can be performed by running a kinematic animation.
If you would like to find out more about any of the features shown in the video today, or any of the other highlights from the release, you can check our website avl.com or look on our simulation blog. See you at the next release.